When 3I/ATLS lit up with an emerald glow, astronomers expected to find diatomic carbon, the usual culprit behind green comets. But when 4 space telescopes locked in on the object, the spectroscopic data showed something no one anticipated. The molecule was missing. Instead, the glow appears to be powered by something else entirely, possibly a chemical reaction involving nickel, or even a substance unknown to science. At nearly 56 kilometers per second, and with a coma larger than Jupiter, 3I/ATLS is behaving more like a deliberate beacon than a drifting rock from the void. And with its interstellar origin confirmed, that possibility no longer sounds so far-fetched. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now, and be part of the few who never stop searching. As October 29th, 2025 approaches, it's perihelion. Scientists and security agencies alike are preparing for what may be the most revealing moment of this object's journey. The glow could intensify. New compounds might emerge, or as some have suggested, the entire event might be part of a broader communication strategy, cloaked in natural phenomena. The absence of iron, the abundance of nickel and cyanogen, and the bizarre energy profile all point to a simple truth. 3I/ATLS doesn't fit any known pattern. Whether it's a message, a machine, or just a cosmic anomaly, what we learn from it could reshape how we understand not just comets, but contact. It's happened again. Another interstellar object. Another question mark streaking across the sky. But this time, the silence from space is louder, brighter, and harder to ignore. 3I/ATLS has entered the solar system, and it's not behaving like anything we've seen before. First confirmed as the 3rd known interstellar visitor, this object is moving fast. Nearly 56 kilometers per second, on a hyperbolic trajectory. It came from somewhere out there far beyond the gravitational grip of the sun, and it's not staying long. But while it's here, it's changing the conversation, because 3I/ATLS isn't just passing through, it's glowing. A violent emerald green glow, so intense, it caught the attention of not one, but 4 space telescopes. They locked on, and they didn't like what they found. Standard comet theory says green means diatomic carbon. That's what makes comets flare green near the sun. It's familiar chemistry, predictable. But when the spectroscopic data came in from 3I/ATLS, that signature wasn't there. No diatomic carbon. None. The glow is real, but the cause is a mystery. And that's not just unexpected, it's unprecedented. 4 space observatories saw the same thing. They ran the numbers, the instruments were fine. The readings were accurate. And still, no trace of the molecule that should have been responsible. Something else is creating that green light. Something we don't understand. Chemical analysis revealed other surprises. The comet's coma, already larger than Jupiter, contains significant amounts of carbon dioxide. That's strange, but not unheard of. Then the levels of cyanogen started to raise eyebrows, and then nickel, high levels. Abundant. But iron, barely detectable. That's a problem. In our solar system, nickel and iron go hand in hand. The cores of planets. The debris in asteroids. The dust in ordinary comets. But 3I/ATLS breaks that rule. It carries nickel without iron, which means it didn't form under the same conditions as objects here. It didn't originate from a star system like ours. Its birthplace was something else entirely. And if the formation was different, what else about it is? There's already speculation that the intense green glow could be the result of a previously unknown molecule, one that doesn't exist, or hasn't been detected in our neighborhood of space. Another theory points to an exotic chemical reaction involving nickel, one that might be releasing energy in a way we haven't observed before, or at least haven't recognized for what it is. And then there's the other possibility, that the glow is deliberate, that it's not a chemical side effect, but a signal. Because if you wanted to be seen, if you wanted to stand out, this is how you'd do it. You'd glow in a frequency that confuses the senses, you'd emit light that doesn't match known signatures. You'd appear natural on the surface, but every detail would pull you further from that category. And if you were trying to conceal something, that green glare might not be a beacon at all, it might be camouflage. The brightness of 3I/ATLS is overwhelming. It's powerful enough to interfere with optical sensors. That's not a side note, it's a strategic consideration. A body this bright creates blind spots, it saturates instruments, it complicates tracking, it opens the door for objects or signals to slip through unnoticed. And that's why this isn't just a scientific event, it's a security concern. Military analysts are paying attention, not because it's a weapon, but because it could be cover. A shield for surveillance, a decoy for something else, an object that hides more than it reveals. Because 3I/ATLS isn't quiet, it's active. This is not the behavior of an ancient inert body drifting through space, it's shedding gas, emitting energy, displaying a coma so large it defies expectations, and it's doing all of this with an energy level that doesn't match its supposed age. Interstellar objects are supposed to be cold, dead, fossil remnants of distant systems, but 3I/ATLS is alive with motion and heat, and timing matters. It's moving toward its closest point to the Sun, perihelion, on October 29, 2025. That's when the radiation will be at its highest. That's when the heat will force more out of it. That's when we might finally see what's hiding beneath the glare. It could be nothing. It could be a new kind of comet, formed in some alien corner of the galaxy with chemistry we've never catalogued. A one-off. A fluke. Or it could be more. Because this is now the third time an interstellar object has entered the solar system. The first, Oumuamua, was quiet, dry, and changed direction without explanation. The second, 2I/Borisov, looked more like a traditional comet, but still carried peculiar signatures. And now this, 3I/ATLS. Glowing, massive, chemically bizarre. Patterns are starting to form. And that's what matters. Because science is built on models. But models fail when confronted with things that don't fit. And 3I/ATLS does not fit. We are looking at a rare opportunity. One that only comes once every few decades, or centuries, or maybe longer. A body not shaped by our sun, not formed from our disk, not limited by our assumptions, and as of now, no theory can fully explain it. That's why both astronomers and defense agencies are watching closely, from multiple angles, with every sensor they can point at it. Because whether it's a message, a relic, a signal, or just a bizarre chunk of cosmic debris, it's valuable. It's data we can't get from Earth. It's a test of everything we think we know. Some hypotheses are cautious, new molecular discoveries, unknown reactions, rare interstellar formation events. Others are less restrained. They entertain the idea of artificial design, of communication, of intention. Not because it's the most likely answer, but because right now nothing is likely, and everything is possible. The unusual chemistry. The glow without the molecule. The overwhelming brightness, the imbalance of nickel and iron. The comet-like activity. The scale of the coma. The interest from both science and military circles. None of it lines up cleanly. That's why 3I/ATLS matters, because it challenges more than equations. It challenges assumptions. It reminds us that space is not empty. It's full of questions. And once in a while, one of those questions comes screaming in from the dark. Faster than anything we've seen, glowing in a way that shouldn't be possible, behaving like it's aware we're watching. October 29th, 2025. That's the day we might get answers. Or more questions. But until then, the telescopes stay fixed on that green light. And so do we. Like, share, subscribe. This is far from over. 3I/ATLS doesn't behave like an object that drifted through interstellar space for a billion years. It behaves like something with purpose. That's not speculation. That's the unavoidable consequence of stacking all the data next to each other and realizing none of it adds up under conventional models. Start with what we can confirm. It's not from here. The trajectory is hyperbolic, meaning it's not orbiting the sun, just passing through. It entered fast, and it'll leave fast. No loop. No return. The solar system is just a stop along the way. That alone is rare. Only 2 other interstellar objects have ever been confirmed. Oumuamua in 2017, 2I/Borisov in 2019, now 3I/ATLS, 3 times in less than a decade. After 0 for centuries. That sudden frequency, 3 interstellar objects, each with strange features, all arriving within a narrow time frame, forces a hard question. Is this a pattern? Oumuamua didn't outgas like a comet, but accelerated anyway. No visible tail, no emission, no explanation. 2I/Borisov looked more familiar, but burned with unexpected intensity. And now 3I/ATLS arrives, glowing green with no detectable source for the glow, emitting signatures that defy our understanding of cosmic chemistry. That's not random. That's statistical pressure building against a model that can't hold the weight. And 3I/ATLS is heavier than both its predecessors, figuratively and literally. Its coma is massive. Larger than Jupiter. That's not artistic exaggeration. That's data from 4 separate telescopes measuring its envelope of gas and dust. An interstellar object with no gravitational tie to the Sun, carrying a shroud bigger than the largest planet in our system, and glowing while it does it. But glowing with what? That's where things get uncomfortable. Because the green hue is familiar. We've seen it before. Diatomic carbon (CFCs) emits green when exposed to solar radiation. Standard comet stuff. Textbook. The problem is this object doesn't have any. Not even traces. The molecule that should be producing the light isn't there. 4 telescopes confirmed it. Not a calibration error. Not atmospheric distortion. Not a glitch. So what is emitting the light? Some suggest a previously uncharacterized molecule, maybe formed only in deep interstellar space under conditions we haven't replicated. Others propose complex interactions between nickel and solar radiation, though that mechanism is still theoretical, and the absence of iron throws it into question. Because that's the other anomaly. Nickel is abundant, iron is not. That violates everything we know about how matter forms in stars. In stellar nucleosynthesis, nickel and iron are close cousins. You don't get one without the other. Especially not in these proportions, but 3I/ATLS is stacked with nickel and barely registers on iron. Its chemical fingerprints look alien. Not metaphorically, literally. Forged in a system where the physics of matter, temperature, pressure, stellar behavior must differ from our own. And if the glow is intentional, whether by accident of formation or by design, that changes everything. Because now we're not just talking about a weird comet, we're talking about a potential marker. The idea is controversial, but it's on the table. A glowing object, unnaturally bright, loaded with chemicals that don't match our models, passing through at a time when we've just developed the tools to study it. It glows in the visible range. It interferes with sensors, it saturates optics, it creates conditions that confuse automated surveillance systems. That doesn't prove intention. But it does demand attention. This isn't idle curiosity anymore. It's not a telescope hobbyist's mystery. Space surveillance systems are involved. Defense agencies are watching. The reason is simple. Any object that large, that bright, and that chemically irregular could present a risk or a message, especially if the brightness is hiding something. Because when a body glows this powerfully in a narrow range, it becomes a mask. It blinds instruments. It floods sensors. It drowns out anything around it, making it an ideal cloak. And that's why 3I/ATLS is a dual-interest object, scientific and strategic. One theory suggests the object's activity could be explained by subsurface volatile exposure to solar radiation. Another suggests exothermic reactions, chemistry activated by sudden heat. But neither accounts for the selective emissions. Neither explains the nickel-to-iron imbalance. Neither fits the curve of energy output. That's when questions start crossing boundaries. When astrophysics alone can't account for what's being observed, defense analysts step in. Because it's not about proof of aliens, it's about recognizing when an object breaks protocol, when it steps out of the expected. And 3I/ATLS isn't just breaking protocol, it's ignoring it entirely. As perihelion approaches, October 29, 2025, the solar intensity will increase. That's the point where the object will be closest to the Sun, absorbing the most radiation, reacting with maximum intensity. That's when the data flood will spike. Spectroscopy, photometry, radio scans, everything goes up, because whatever this thing is, that's when it will show its hand. Either the glow intensifies, amplifying existing anomalies, or it breaks apart, revealing internal structure. Maybe it darkens, maybe it splits. Maybe it releases more unexpected elements. No one knows. That moment is critical, because it's the only window we get before it's gone. 3I/ATLS isn't coming back. It will pass perihelion, and then leave the solar system forever. No orbit. No second look. One chance. One opportunity to confirm whether we're looking at a natural interstellar relic, or something stranger, and the world will be watching. Astronomers, military analysts, planetary scientists, every angle covered. Not because we expect aliens to burst out of it, but because we don't understand what it is. And that's enough to keep every scope pointed and every model running overtime. Because if it's natural, then nature is deeper than we thought. And if it's not, then we've just seen the first technological echo from somewhere else. It wouldn't be communication in the way we think of it. Not a signal with words or codes. But structure, chemistry, trajectory, visibility. Intentional or not, the object has become a message, simply by violating every standard we thought applied to bodies of its kind. It has value, not just as a mystery, but as a mirror, because if we can't explain it, we have to ask what that says about our models, our expectations, and the limits of what we call known. That's why this matters. Because 3I/ATLS doesn't just stretch the data, it bends the boundary between science and something else, something that may still be natural, but isn't from here. Something we didn't know existed, but now can't ignore. And the deeper the analysis goes, the more this object resists explanation. Everything about it is a contradiction. It behaves like a comet, but it doesn't outgas the usual way. It emits light, but the source compound is missing. It carries familiar elements, but in unfamiliar proportions. It arrives alone, but at a time when we're finally able to see it. And its glow, the one visible signature we can study, is off the charts, without a source, and without precedent. That's what we're dealing with. A body that refuses to behave, a fragment of some other star system, maybe one that never formed planets like ours, maybe one that burned differently, collapsed uniquely, built matter in ways our physics doesn't yet account for. Or maybe something more, something built, something sent. That's not certainty, it's a boundary condition. The point where the known ends and the unknown begins, where the questions get louder than the answers. 3I/ATLS isn't proof of life, but it is proof that not everything in the galaxy fits our understanding, and it's still coming closer. On October 29, 2025, we'll know more. We'll see how it reacts to peak solar radiation. We'll get the last and only chance to capture detailed data, but no matter what happens, this object has already left a mark. Not on the sky, on the framework we use to understand what the sky is. Because now we know. There's more out there, not just in distance, but in possibility. We've been looking for signs. We've been waiting for proof. Sometimes the universe answers with a question, and this one's glowing green. There's a reason 3I/ATLS feels different. Not because it's the first of its kind. It isn't. But because it's the loudest, not in sound, not in signal. In behavior, it doesn't whisper like Oumuamua, it doesn't mimic like 2I/Borisov, it announces itself visually, chemically and energetically, with a brilliance no one was ready for. A comet that shouldn't be glowing. That does. A body that shouldn't be active, that is. A traveler from deep interstellar space that refuses to be just another object catalogued and filed away. This thing demands attention. And that glow, it's still the core of the mystery. That emerald green halo isn't an optical illusion. It's not a trick of distance or heat distortion. It's real. But it isn't acting like anything we've seen. Not from any comet. Not from any known chemistry. It looks like diatomic carbon, but it's not. The expected emission lines are missing. The spectrum is off. The intensity is wrong. So the question remains, why is it glowing? Maybe it's a reaction we don't yet understand. Maybe it's a material forged in alien conditions, something stable in deep cold, that becomes volatile under solar heat. A molecule unknown to us, shedding photons in a range that coincidentally matches Sathal, but without being Sather at all. Or maybe it's something designed to look familiar enough to pass first glance, but wrong enough to trigger a second look. And here we are. Looking, because if you were sending a message across the void, would you send it in a way that could be heard by anyone, or would you make it look like noise, until someone listening closely realizes it isn't? This object may be natural. It probably is. But that probably is shrinking with every new reading, with every abnormal data point, with every contradiction between what we expect and what we observe. It doesn't mean alien. It doesn't mean intention, but it does mean we don't know what we're looking at. And in science, especially in astronomy, that's rare. Most things fall into place. Most objects get sorted into known categories. Even when they're new, they echo the old. 3I/ATLS does not echo. It disrupts. And now the countdown begins. October 29th, 2025. The moment of closest approach to the sun, the moment the heat peaks, the moment everything hidden either burns off or breaks open. That's when we'll know if it's just rock and ice from a distant system, or if it's something far more disruptive, more complex, maybe even more deliberate. But whatever it is, it's already served its purpose. It's reminded us how little we know. How thin the boundary is between explanation and mystery. How quickly confidence turns into silence when the data refuses to play by the rules. 3I/ATLS came from out there. And it's leaving soon. But not without leaving questions in its wake. Like, share, subscribe. You don't want to miss what comes next.